All right, so today we are doing subtracting algebraic expressions, which is a little difficult. So you're definitely going to have to pay attention and stay with us as we go. The biggest thing here is that when there's a negative between parentheses, or when there's a negative in front of parentheses, it has to go to every term that is in those parentheses following. And that's what throws people off. We're going to skip the launch.
How's your day been going?
It's been going wonderfully. How's yours?
Good.
What did you guys think about Chris's presentation this morning?
Good.
Yeah. Anyone?
I did the homework.
Chris, the guy who was talking.
I want to be.
Yeah. None of the 8th graders figured out how to honk the horn.
Mr. Hudson, I've
Yeah,
never
none.
heard of pit bull before. What?
Yeah, that's a pit mix.
His name is Benny.
I know, Benny's awesome. All right, so check this out. These two methods are on your paper.
Subtract each term inside the
We're going
parentheses.
to treat the minus. We're going to treat the minus like it's a negative.
Remember
And
that
we're
the
just going to
subtraction
distribute
sign
the
inside the
negative
parentheses is
So
the
on
sign
your
of the
paper,
second
you
term,
want to draw the
negative
arrows.
7 times x.
You want to draw the arrows, and I might as well just pull up a copy of the notes.
Subtracting negative 7 times x is the same as adding positive 7 times x.
Here.
Group like
So
terms.
the negative goes to the 2. Hey,
Then combine the like terms.
we're in math. Draw those arrows to show that the negative distributes to both value, the 2 and the negative 7. Then that's why, like, essentially, you're taking this parentheses and making it the opposite of what it was. So it was a positive 2 and a negative 7x. Now it's a negative 2 and a positive 7x. And negative 2, everybody kind of has this debate all the time. Minus and negative are the same thing. So whether you say it as a minus or whether you say it as a negative doesn't really make a difference. So here we can say that it's a minus 2, but it's really negative 2 because it was the opposite of what it was. Now the other method, actually I should capture that really quick. The other
Rewrite
method,
subtraction as addition.
Could I please have Ty Hunt to the office? Ty?
we treat
Subtracting the
this
quantity
like
2
negative
minus
1
7
because
times
does multiply
x
by
is
1
the same as adding negative 1 times the
So,
quantity
does multiply
2
by a
minus
negative
7 times x.
Yeah, it makes it the opposite of what it was. So when
Distribute
you
the negative 1.
multiplication, which on your notes, I want you to draw the arrow that negative 1 is distributing to both of these. That's how we then get the negative 1 times the 2 and the negative 1 times the 7. Now here's the problem. And what I
Adding a negative number is the same as subtracting, while
Here,
subtracting a
they
negative
use
is
that
the same
as
as
a
adding a
minus.
positive.
I don't like doing that. I like taking it with the 7x.
Group
So I
like
would've
terms.
Here actually had plus negative
Then
1
combine the
times
like
negative
terms.
7x. Either way you do it, you're still going to end up with the same answer. So like I said, that could be a minus. It could be a negative. Either way you do it, you're going to get the same answer. Questions? Questions will happen after we try a couple. So look down at the examples. I'm actually going to help you with the second one and the third one, and then you guys are going to do the first one on your own. So, work with me here. This negative distributes to the 1/4 p, and it distributes to the negative 1 or the minus 1. Now, how I remember this is just take the parentheses and make everything the opposite. So did anything happen with my 1/3 p minus 9? No, it stays the same, so rewrite it. 1/3 p minus 9. Now, 1/4 p, the opposite of that would be negative 1/4 p. And guys, we can always assume addition between terms as long as we put the sign of the term with the term. So this will become subtraction, but for the moment, I'm assuming addition. Then plus, guys, I see a lot of you not working, like not writing. The opposite of negative 1 is a positive 1. You don't need to put that positive in there. You don't even need to put it in parentheses. I'm just doing it to show out the details. Then, what's it called when we move terms around? What property allows me to move terms around in addition or multiplication? Isaiah? Huh? That is changing what is in the parentheses. So we kind of do that here. Commutative. To commute means to move. So I'm going to apply the commutative property and now have 1/3 p. I'm actually going to draw a little line between. This is not division. This is just so I can see the separation. 1/3 p minus 1/4 p. I now can rewrite it. So now I don't need to put plus a negative. I can just make it minus. Then -9 plus 1. If you have a highlighter, I always think it's nice to highlight my like terms and separate the colors, especially if on the multiple intelligences questionnaire, if you came up as artistic or visual spatial, highlighting and using the colors is extremely beneficial to your brain.
Which one did you say it was?
Visual spatial or kind of like the artistic. I mean, you don't have to check your MI right now. But what I'm saying is like, really it benefits everybody, but especially those visual spatial people. What's the issue with combining my p values? What's the problem here? Luke?
It'll get smaller than
Thomas?
You need to use common denominators.
We have to have common denominators. 3 and 4. Thomas, do you know the common denominator? 12. So, if you do this in your head, okay, but I warn you, that's how you make mistakes. I show out. This is really, I could use a pen. To make this 12, I multiply by 4 on top and bottom. To make that 12, I multiply by 3 on top and bottom. So now, with common denominators, this becomes 4/12 p minus 3/12 p minus 9 plus 1.
Okay, I think I can figure this out.
Yeah, how many p do I end up with then?
4/12 minus 3/12 plus 1 p. What? The p? Hold on.
Do your numerators, keep your denominator. So 4 minus 3?
1/12.
So we get 1/12 p. -9 plus 1, Cassidy? You're not Cassidy. Cassidy, I didn't know you could throw your voice and make it sound like Luke. It is -8. 1/12 p minus 8. Or you could put plus -8, but we don't do that because it's kind of redundant.
What does redundant mean?
It's like repetitive or unnecessary.
Oh, I think I did it.
So when you're walking down the hall and you're like, Eli, that's redundant. You could have just said, hey, Eli, once, and you would have probably got his attention. This situation. This normally throws people off because now we don't just have a negative, we have a number involved. Now most of your homework just has the minus or the negative between, but a couple of them have the number. So I want you guys to circle this -2 and then show the distribution. We're going to write out like the whole process here. So I have -1.5h plus 3. Then I'm assuming addition, -2 times -0.5. Assume addition, -2 times 4h. Questions on what I've done so far? All I did was distribute. The sign in front of the number, or the term, goes with the term. So, now I have to do this multiplication. So again, this doesn't change. I just rewrite them. -2 times a -half. Negative times a negative? Positive. Half of 2, it's 1. So I have plus 1. And then negative 2 times 4.
Ooh, -8.
Negative 8. So I write minus 8h. Now we're looking for like terms.
Ooh, it's negative 1.5h plus negative 8h.
Now, Emmanuel, why'd you say it like that? I like that you said it like that, but do you know why it's nice to say it like that?
Because 1.5h is the first number.
But you said plus a negative 8. I like that you said it like that. With values that have the same sign, when we add the same sign, we add the values, keep the sign. If you had written this as negative 1.5h minus 8h, that confuses some of you. You get a little stuck. But if I say I have a negative and another negative, I'm going to get a bigger negative. So I get negative 9.5h plus 4. And that's it. Do that first one on the left on your own. That first one. The 16 minus 3 plus 8 thing. Then you get done with that, move on to either the, well actually the next got it we're kind of running out of space on. Careful how big you're writing things. Yep, you would draw arrows from the negative to both of those terms. Once you have your answer, glance up here. You should have 8m minus 3. Now we could write negative 3 plus 8m, but we like to put variable terms first. So we'll go variable term, then constant. Questions? Brianna?
Oh, wait, never mind.
You got it?
Never mind.
I think I get it now.
Yeah?
What I did was, I don't think it was right, but I did like 16m, like plus negative 3.
That's
plus
fine.
negative 8m.
That's fine.
Oh, okay.
Because 16m plus negative 8m still gives you 8m. It's just a little bit more complicated of a way to write it. We like to do plus the negative if my first value is a negative. So if you have a negative plus another negative, that's when we like to write plus the negative. Here we didn't need to because just looking at it as subtraction was just as easy.
But, so would that still be right?
Well, did you get the right answer?
16m plus negative 11.
Ah, you combined your 8m and your 3. You cannot combine these because they're, anyone know? Luke?
Not like terms.
They're not like terms. So you have to only combine your like terms. So you need to go back and erase and combine your like terms and get that 8m minus 3. Thomas, question?
So, why don't we like 8m plus, wait, no. Why don't we like 3 plus a negative 8m?
It would be negative 3 plus 8m. Because my 8m was positive, my 3 was negative. The sign in front of it goes with it. One reason we don't like that is because you have to start with a negative. It's not as nice as just making it subtraction. The other reason is just mathematically, we put our unknown values first. This is a known value and then an unknown. So we'd rather write it 8m minus 3 because once I know what m is, I could plug it in and then subtract 3. So if m was 2, this now becomes 16 minus 3. If m was 4, it becomes 32 minus 3. And then that's just easier. That makes sense? Not, well, okay, I guess I can capture. Don't capture again. Try the Goddard on your own. Same basic thing, but now we have a binomial, 2 terms, minus 2 other terms. I'm not worried. I should have just cut this out of the paper. I'm not worried about which of these are the same, but if you want like bonus, and obviously it's not worth anything, but if you want bonus, figure out which of those expressions would be the same as your answer for here. So first thing you have to do is distribute the negative or the minus and figure out what that answer is. Yeah. Guys, this is a harder lesson. I forgot to say, your homework is due Tuesday. So if you have questions, I want to start class Monday by taking questions. So your homework is due Tuesday. Huh? If you understand it, it's okay. Wait, where's your work? Yeah. Yeah. So then combine the like terms and solve. So Bella just asked me to check her paper, and she didn't do the work, but what's interesting is she's getting the right values because, actually, do you have one circled? If you have one circled, you should not. Here's what's up. These become the opposite of what they are. The 6y and the 15 don't change, but then this becomes a negative 4 or a minus 4, and this becomes a positive 8y because they become the opposite of what they were. So if I look for which of these have that, number 2 would have it, and also number 4, and also number 3. They would all be equivalent expressions here. Yeah, except for number 1. And when we combine them, then we would get 14y plus 11. This is the easiest one to look at for combining the like terms. Try this on your own because now we have a negative 2. My advice is circle the negative 2 and distribute, showing that the negative 2 distributes. So the first thing you should do is drop down what doesn't change and then show the assumed addition and the first multiplication plus the second multiplication. Did not go as high as I anticipated. If you have any issues, please stick up a hand. Read that down too. I do that occasionally. Where your breath just like catches your throat. Who has please don't. That is a if I knocked you outside. Huh?
When I get cold, it usually goes down in my chest.
Yeah.
And I have a bad
So, we're going to start using cards. Huh? Okay. But it's a negative 2. That's why I said circle the negative 2 and draw the arrows. Now you just circled the negative. You want to circle the whole negative 2 and then draw the arrows. You jumped right to the answer, but yeah, you want to show your workout. We're going to go over it together, so hang on to those. Crystal, my first multiplication, my first arrow here. Sorry, you saying you want to pass? What's the first multiplication that happens? Yeah, negative 2 times 2.7. Abby, what's the next multiplication that should happen?
Negative 2 times 0.25.
Uh-huh. I ran out of space for my x. Yeah. So then, do those multiplications. That gives me negative 5.4 and a negative 0.5x. Now, here's where we want to rearrange or look for my like terms.
2.5x plus negative 0.5.
Now, instead of putting plus a negative, I'm just going to put a minus. Then we combine the like terms, and we get how many x? 3x minus 5.4. Guys, when you're doing your homework, you need to be referencing your notes. This will help you immensely, especially this step-by-step process. When you've got a number with the negative, they both distribute, and it will help you if you write out what multiplication is happening. Karina?
But it's hard for me because when I use notes and then we have the test, we don't have the notes, so it's hard.
But using the notes helps put it in your memory.
But
It
sometimes,
really does.
Mr. Hudson's very nice.
Yeah, sometimes the last 10 minutes of the test you will get notes, especially as you get into harder and harder content.
When does that happen? Yeah.
We aren't far enough in the year yet.
Oh, we already have
Like last year,
So-
last year you put like the whatever, I forget what it was. Like,
What?
You put like two different formulas for
Oh yeah, I gave you the formulas on the notes on the percent application test. Yeah. Questions on this? Good. Move on to the back. All right. So, hey, you've already made your mistakes. If you're gonna make your mistakes, so try this on your own. Do not make a single mistake. I'm not like grading this now. I'm just saying I'm challenging you. Be careful. Pay attention to the details. Try to do this without making mistakes. If you're struggling, stick up a hand so I can help you. Hold on. First off, sorry. That question mark, I hate when Digits does this. That question mark annoys me because it shouldn't really be there. So ignore the fact that it's there. It's from the question, but some students will be like, wait, why is there, like, what does the question mark do? So you can scribble it out if you want or something. So, distribute the negative, and because there's no number, it essentially is just going to make these values the opposite of what they currently are. So this is it's a positive now, so it becomes, and this is a negative right now, so it becomes positive. Remember to drop down anything that does not change. What's up? It's on 4. Yeah, but now you gotta combine like terms. Oh man. Oh man.
Yes, I got it.
Sorry.
I did it.
Combine.
I have no idea.
Wait, no, I'm just confused.
For some reason I thought we were standing there.
I don't either.
Isaiah. Depends if you're adding or multiplying. So, if you are in debt to your dad $10, that's like a negative, right? And then you borrow another $2, taking your debt $2 more. You're now in debt.
So it'd be 9 negative 11.
Yes. Hey guys, I've already, if you can't tell, I'm losing my voice. I'm not going to talk over you. The last two problems are harder, and there are problems identical on your homework. I'm telling you, there's identical problems to this on your homework. So, Isaiah, what's the first thing you did here? Yeah, we distribute the negative. And if we're really good, if we're really paying attention, we know that these drop down, and then these just become the opposite of what they were. So that's now a negative 2x, and this is now a positive 1. Any questions with that? Crystal? It can, but it doesn't do anything. So you can, but I get rid of them since they don't do anything anymore.
Can I do the whole?
I'm cards. Sorry. At this point, I'm cardsing. Eli, what do I do now if I'm doing every step?
Can I pass?
You can pass. Zach?
Multiply. Wait, after you multiply?
Yeah, after we've already distributed. What do I do now?
You do the like terms.
Yeah, we combine like terms. So I was kind of doing this whole thing because if you're writing every step, you would move your like terms together like that. You would commutative property. There's one question on your homework that asks you what properties are being applied. So remember, distributive distributes multiplication, commutative moves, it commutes. So now what, I forget who was asking, Cassidy?
Okay, can I tell the answer?
Yeah, well, so the negative 9x and the negative 2x
Oh, negative 9x and negative 2x.
give us.
Negative 11x plus 16.
Yes, ma'am.
I know who
Yes.
So here's the thing. Hey, if you want to have the best help on your homework, we distributed, then we commutative, then we combined. Those are the operations that we did. Yeah.
So proud of myself.
I'm proud of you too.
The first one I've gotten wrong is wrong. Right.
So,
Oh, you're laughing.
Jackson and Aaron are going to the grocery store.
Who?
Jackson and Aaron.
Those are people who go to school.
I know. Oh
It's
my
actually
gosh.
pretty creepy.
So, they're common names. So, Jackson buys a watermelon for $7.45. He buys 3 pounds of cherries, but the price tag has been ripped off. They don't know how much a pound of cherries costs. Aaron buys a pineapple, costs $3.50, and 2 pounds of cherries, but again, we don't know how much cherries cost. So, how could we write an expression for their total? We're going to do 2 things here. So try to leave space so that you can fit 2 different, like, I would almost like draw a line because we're going to do 2 different things. How do we write an expression for their total? Franny, can you tell me how we would start with representing what Jackson bought? So we know the 7.45, right? Like that's money. We know what it is. But what do we do about the cherries? Yeah. We can represent the cherries with just 3C. And if we're finding the total of what they bought, Aaron bought $3.50 worth of a pineapple, and then 2C. We could commutative and make this 7.45 plus 3.50. It's money, so I put 2 decimal places even if it's not necessary. And we combine these. How much money total? What's the constant really? $10, 95 cents
Plus 5C.
5C. Now, if we want to really write this mathematically correct, we would flip it around and put the 5C first. They're both right. They're both right. But mathematicians, we just like to put the variable terms first. And then when you get farther in this, we put the higher power variable terms first.
I get it.
So if there was like a c squared or something. Now, write an expression to represent how much more one friend spent than the other. Who spent more money? Jackson, right? So we're going to take Jackson's purchase. Guys, I'm telling you there's a problem identical to this on your homework.
Like the same store.
Same setup. Yeah, two friends go to the store. Yeah. Then subtract. Hey, it's okay. I'm coming in to clean that stuff out this weekend. Then subtract Aaron's purchase.
Minus 2c.
Now, Aaron's purchase right now is plus because that's in this parentheses is everything Aaron purchased. Then we have to. Brennan is in the restroom or somewhere. Layla. You were right. Not yet. You were right the first time. Distribute this negative. So distributes to here and to here. Guys, when you're just distributing a negative, just think opposites. So now I have 7.45 plus 3c minus 3.50 minus 2c. Wait. We do not. I mean, you could put plus negative 2c if you wanted. We don't have to. Rearrange. And then combine and find the difference of each, the difference of the constants and the difference of the variables. Yeah? Try, if you are done with this, try the got it on your own, but now it's an area problem. No aw. It's fun. It's an adventure. It's a challenge. If you are finding partial regions, so you're finding the area of just this shaded region, we would want to find the area of the whole thing and then take away the area of this. Because if you want to, so essentially this is what we nickname as a donut problem. If you have a figure that looks like a donut and you're trying to say what is this area, or it looks like a Pokeball.
Pokeball.
You find the entire area, so the entire thing, and then subtract away this portion to leave you with just the blue. So you need to, then I'm going to walk around and help people. You need to find the area of the entire big rectangle minus the area of the small rectangle.
Isn't area 11 times 5?
Yes. Yes, sir.
I think that donut thing, when you shaded the outside part, it looked like a donut with the outside.
Yeah.
Merry Christmas.
How are we doing, Brian?
We have to find the expression.
Because you need to, what would be best first is to get that on the screen copied down because you have a problem identical to this in the homework. Like, I guarantee you it's a two friends go to the grocery store, et cetera, et cetera. If this large is x and this is 2 and that's 2, whether we call it length or width, I don't really care. Yeah, it's 4 plus x. Times, if this, I don't think so, is 6, and this is 2, and that's 2, what's the total length? 10. So now we really have 10 times 4 plus x for the big area. That really, when I distribute in, will be 40 plus 10x. Then for my inner, Well, it's just x times 6. So 6x. So then, to find just the shaded, yeah, we'll take the big or the total minus the inner. So this now will be our 40 plus 10x minus the 6x. I think you're right. Ah, you can't combine unlike terms. You combined unlike terms. So before you combined, what'd you have? You should get 40 plus 4x.
That's what I got. That's what I got.
Questions? Because the 10x minus the 6's. Yeah, yeah. We